Okay, 3.1, mostly going to be talking about alternate interior, exterior angles, corresponding angles, but we also want to understand skew lines and parallel lines. So consider the lines that contain the segments in the figure and the planes that contain the faces of the figure. Okay, it's important to understand that it says that all angles are right angles, all right? So it's giving you that. Which lines or planes contain point B? So we're focusing on point B here, and that it appeared to fit the descriptions. All right, so number one, lines parallel to CD. So a line parallel to CD, okay, would be, that includes B, all right? So we want a line that includes B. You could do, let's see, CD would be AB. So if we look at those, there's CD, there's AB, those are parallel. All right, so number 3, lines skew to CD. All right, so skew to CD means that they're not parallel and they don't intersect. So if we look at CD, we need a line that's not parallel that includes point B and is skew to CD. All right, well, if I look at BF, BF is not parallel to CD, and nor does it intersect CD. Okay, so line BF, excuse me, is skew. Okay, so there are your first 4 answers. You just are doing the odds, but just in case you wanted to practice. All right. It doesn't say anything about these lines. You have to go by what it's saying. So I want to point out a couple things here. That these little marks mean that those 2 lines are parallel to each other. And you see a 90-degree mark there. And I think that's all we have there. All right, so number 5. Name a pair of parallel lines. All right, so how do you name lines? You need 2 points or a lowercase letter. So MK is parallel to LS. Make sure you grab the right letters. Okay, and number 7 is PN. So let's highlight PN. So PN is, I'll do it in blue. This line right here is PN parallel to KM. Here's KM. And of course, those are not parallel. Okay, they're not marked as being parallel and they intersect. That would be the best explanation. They intersect. And parallel lines do not intersect. Okay, all right. Okay, there's the answers for all of them. Number 9, identify all pairs of angles of the given type. All right, so corresponding. So just like in class, corresponding means same positions. So what I'm going to do is I'm going to redraw this as one thing here. So corresponding from this section, intersection to that section, if we put one on top of the other, we have 1 and 5 are here. 2 and 6 are in the top right position. Okay, 1 and 5. And then you have 3 and 7 in the left lower position. And then you have 8 and 4 in the lower right position. All right, so corresponding angles, all the pairs, it says all the pairs. So there we just named them. So number 9, you would say angle 1 and angle 5, angle 2 and angle 6 go together, angle 3 and angle 7, and angle 4 and angle 8. That's what you need to do. Number 11, alternate exterior angles. So let me clean this up a little bit here. Alternate exterior angles. Excuse me. Exterior. So it's going to be on opposite sides of the transversal. All right. And alternating, exterior meaning on the outside. So let me say this is the inside. So we don't want 3 and 4 and 5 and 6. We don't want those because they're on the inside. We only want exterior angles. So they have to be on the outside of these 2 lines here. Okay, so this is exterior and this is exterior. Now alternating means on the other side of the transversal. Okay, now what we don't want to do is say this. Hey, 7 and 8 are alternate exterior angles. No. Yes, they are both on the exterior side and they are alternating around the transversal. But what they're saying is they want alternating on the from one intersection to the other intersection. So if we're talking about angle 7, we can't use 8 because it's at the same intersection. So that means we have to use angle 2. So angle 7 and angle 2 are alternate exterior angles, as well as angle 1 and angle 8. All right, number 13. All right, now given the answer, how do we describe angle 5 and angle 1? So number 13, angle 5 and angle 1. So from this intersection to that intersection, both of those are in the upper left-hand position. So that would mean they are corresponding angles. All right, now number 15. Let's use blue now. 6 and 13. So here's 6 and 13. So from this intersection to that intersection, they're both on the inside of the two lines. Okay, use right here. This line and that line. They're on the inside of this line. Okay, those two lines. So they have to be interior, right? This is interior, and this is exterior. And they're on the same side of the transversal. Okay, so what we call that is consecutive if they're on the same side. So you have to remember what consecutive means. Same side of the transversal. So right here is the transversal. So let me draw this out here for you a little bit better. So just that transversal, here's your transversal. Okay, we have 6 and 13 here. This is the interior, and they're on the same side of the transversal. So that means consecutive, and since they're inside, that's interior, consecutive interior angle. So now you can see the evens as well. Moving on to number 17. What did they do wrong? Okay, so there really isn't something to just go ahead and do the problem with. You have to look and see what they said here. If two lines do not intersect, then they are parallel. Okay, so we now know three-dimensionally, if we look at a box, okay, that this line here does not intersect with that line back there. Okay, three-dimensionally you can figure that out. And this line doesn't intersect with this line either. So both of those don't intersect with that far right line. All right, so two lines that do not intersect are called skew lines. That's what you need to say. Okay, number 19. Modeling real life. Use the image to determine whether the line containing the main vent, okay, so let's just draw this. Here's the main vent, is skew to the line containing the secondary vent. Here's the secondary vent. Well, skew means they don't intersect, and these intersect. So, use the image to determine whether the line containing them is skew. Well, no, they're not skew. Okay, number 28. I know it's not odd, but I want you to do it. Name the property that the statement FG is congruent to FG. Something that you see when you look in the mirror. Okay, that's reflexive. That's the property. So hopefully you're stopping these and trying to answer before you look at the answer. Number 29, classify the pair of numbered angles. Okay, so this is exterior, exterior. This is your transversal. So they're on opposite sides of the transversal. So alternating sides. So this would be alternate exterior angles. Okay, a few more. 31, solve the system. The only way you can solve equations that have two variables is if you have two equations, and here we have two equations. Secondly, what you have to do is solve for one variable and substitute it in the other, or you can do elimination. I'm not going to go ahead and explain elimination again to you guys. Let's just solve for one variable. But the first thing I want to do is I want to remove my decimals, so I'm going to multiply by 10 in this equation, and that gives me negative 5x. Multiplying by powers of 10 moves your decimal, the amount of zeros to the right. 5x minus 15y equals negative 70. And here at the bottom, I'm going to multiply by 10 as well. And that gives me 35x plus 15y equals 40. Now, I'd really like to do elimination, but most of you are happy with substitution, so I'll do substitution. I'm going to go ahead and just solve the first equation for y. So that means I need to add 5x to the right. So I have a negative 15y equals positive 5x minus 70. Now I divide off the negative 15 for everything. You're not going to get away from the fractions, especially after this class. Y equals a negative. 5 over 15 is 1/3. And 15 goes into 70. Only 5 times 15 is 75. So 4 times 15 is 60. So we can reduce this by 5s. And that becomes, let's see, 14. And 15 divided by 5 is 3. So that's negative 14/3. Okay, so you have a minus sign, and a negative 14/3 makes plus 14/3. Now we can substitute that in for that y. 35x plus 15, and the y is negative 1/3 x plus 14/3 equals 40. So let's distribute this and slow it down. It definitely would have been faster to use elimination. So now we're going to take the 15 times negative 1 over 3x plus the 15 times the 14/3. And watch what happens here. The 3's will reduce with the 15 by 3. So that gives us a 1 and a 5. Same thing on the other one. The 3's and the 15 reduce by 3. So what do we have? We have 35x plus negative 5x, and 5 times 14 is 70 equals 40. 35x minus 5x is 30x. We subtract 70 from 40, we get negative 30. And now we divide by 30, and x equals negative 1. So divide by 30. Negative 30 over 30 is negative 1. Now we just substitute this back in here. Y equals negative 1/3 times 1, negative 1, plus 14/3. Look what happens. A negative times a negative is a positive, so that becomes positive 1/3 plus 14/3, which is 15/3, or 5. So our solution is negative 1, 5, a coordinate where the two lines intersect. That coordinate on the graph would be negative 1, 5. Okay, let's check the answer. And there it is. Last problem. Approve. Just a reminder, if you don't do this, you get a 0. I'm showing you how to do it, so all you have to do is copy it down. But I would suggest you figure this out. Angle 1 and angle 3 are complementary. Try to do this. And angle 2 and angle 4 are complementary. Those are given. Okay. We also know, now we're trying to prove this. That's going to be down here. Angle 1 is congruent to angle 4. All right, so that should be easy, that should be easy, that should be easy. Those three things you should be able to write down. Now, why is angle 1 congruent to angle 4? Why are those two congruent? Now, they're corresponding, they're alternate interior angles, but we don't know if these two lines are parallel, okay? So what we want to do is just kind of follow through. We have angle 1 and angle 3 are congruent. So let's just use a single arc here and angle 3. Those two are congruent. we'll use a double arc for angle 2 and angle 4 because you don't know that the two are equal, that all of them are equal. So the very next thing I notice, and what you should notice always, is this right here. You have angle 2 is congruent to angle 3, the vertical angles theorem. So just like in the other proofs we've done, anytime you have a proof, look at the given and you probably should go from there. I was just pointing out the obvious. You could say vertical angles are congruent at any time. I went ahead and said it then. But I see that they're complementary, so that means the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. Definition of complementary angles. Okay, so I mean, we probably skipped a step here, a couple steps. You probably want to say the measure of angle 1 plus the measure of angle 3 equals 90. The measure of angle 2 plus the measure of angle 4 is equal to 90. And those are really the definitions of complementary angles. And then you see you have the transitive property there. So that's probably the proper way of doing it. So notice you have the beginning is to the middle as the middle is to the end, so the beginning is to the end. All right, so you have the transitive property there to say that. And then we said angle 2 is congruent to angle 3. Therefore, you can say the measure of angle 2 equals the measure of angle 3. And that's the definition of congruence, I should say. If two angles are congruent, then their measurements are equal, okay? And vice versa. So now we can substitute these things in. So let's write this a little bit bigger here. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 4. That's the substitution property. I substituted angle 2 for angle 3. And then if I subtract the measure of angle 2 out, I have the measure of angle 1 equals the measure of angle 4. That would be subtraction property of equality. And notice now, if they are equal, then they are congruent, which is what we just said, definition of congruence. Definition of congruent angles, if you want. So let's take a look and see what the book had. Okay, so there you go. You have how they did it. Pretty close to how I did. I did the vertical angles before I did anything else. And it pretty much went about the same way. There you go.